Okay, I go to the first example of here. Okay, just now I have mentioned to you the IJKL. Okay, if you refer to this example here, okay, in this question, even though they say that they consist of the 3 replicates, but if you observe it, they only run the replicate is when they do not have a block, because for the 1 they repeat for 3 times. So therefore, in this example here, altogether you have the overall treatment combination is only 12 of them. Only 12 of them. Therefore, the L here it shouldn't be 1, 2, 3. The L is only 1. You only for each one you only have 1. So I make the correction of here. I remove it. The L is only 1. Okay. So therefore, the L here is only you have only a single replicate, because if you observe it, here is a 2. For the I is a 2 levels. For the J is a 2 levels. For the block is a 3 levels here. So 2 times 2 is 4. 4 times 3 is a 12. So it's equal to all together is only 12. So therefore, the L is equal to 1. Means that you only have a 1 replicates here. Okay. They are referred to here in this question, they refer to a 3 replicate is because for the 1, they repeat for 3 times. Therefore, they consist of the 3 replicates here. So because they say the replicate here is a hash material. For each raw material of them, they run in the block. So in fact, your overall, you only have altogether is a 12 treatment combination, because your N is referred to observation you run. So therefore, they have a 12 only. And then in this one, the L is only 1. Okay, you have a 2 times 2, 2 times 3, you get the 12 of them. So the L is only 1. Means that for each cell is only 1 observation. Okay, so I need to clarify here. Okay, it's not 1, 2, 3, only 1. So we go back to the same the here. Just recall back what you have here just now. The blocking here, I have 3 blocks where all the 3 blocks will run completely all the treatment combination. Okay, 1 A, B, and the AB, all the combination you run. However, just now we don't want to run all the treatment combination because we not enough the raw material to run. So therefore, we run less treatment combination within a block. Okay. So this is the idea of the confounding, where we run number of the blocks will be combination. So the 2 power of k will be is a total number of the factorial design. Then you only run is a 2 power of p in complete block. So where the p will less than the k. So in that case, you only can be run in the 2 blocks. You cannot run for the 3 blocks, or you want to run for the 5 blocks, cannot. You only can run in the 2 blocks, 4 blocks, and the 8 blocks, and so on. Okay. So because of you only run certain treatment combination in each of the blocks. Okay. For example, in this one, you only run, let's say the block 1, you only run the 1 and the A. You run the B and AB, and so on. So therefore, you will lose certain information. So what is depends on which factor you are confounding with the block. So for example of the first example here, if I run the block 1 consists of the 1 and the AB, the block 2 consists of A and the B. Okay, how do I assign the 1 and the A and the B in the same block? Is depends on the table here, where those of the plus sign you group them together, those of the negative sign group them together, then you can check it out. So if the AB is confounded with the block, means that the information of the AB you cannot get it anymore, because the sum of square for the AB will be grouped together with the sum of square for block. So therefore, you will lose the information of the information of the AB. Okay, you are unable to retrieve the information of the AB. Okay, because you are willing to run only 2 blocks and then with the incomplete blocks. Unless you run all the complete blocks, then you can get the information of the AB. So this one is a payoff. Okay, if you run less treatment combination with it within the blocks. Okay, so we are not doing this one. Is I just there for you how we want to do the confounding, but we are never do confounded. Confound A is confounded with the block. We never do this thing because A is your main interest. Your factors is your interest. So if you do it in confounded in the block, means that the information from the A, you cannot extract it out. So that one is no value for your this experiment, because your experiment you want to looking at the factor A and the factor B. But you confounded it itself, therefore you don't have the information on A. Okay, so bear in mind that when you do for the confounding, you make sure that you need to know which factor are you going to block it confounded with the block. Okay. So the usual practice is confounded with the high order iteration, because especially the high order iteration is not our interest. Therefore, we will give out the information of the high order iteration. Okay. So now I have a two case. I have a show you. Okay, before I go to the two cases, here I show you another example. Is if we have a 2 power of 3 fractional design. Want to have a do the confounding, then we can use the ABC to do the grouping. So we can be referred to this table. If I want to confound it with the ABC, then I group those of the negative together, those of the positive together. So this one is the first block, this one is the second block. So this one is means that ABC will confound it with the block. So in the other word, the ABC information you can't retrieve it anymore, because you run less treatment combination within the block, therefore you will lose the information here. Okay, so also this information is not, you feel that it's not important. The ABC iteration is not important. Therefore, you do it in the confounded with the block. Okay. So this is an example of the this is an example for the 2 power is a 2 power of 4 factorial design. Okay, they put it in the 2 blocks here. They do it in the 2 blocks where each block consists of the 16 treatment combination. Okay, so in this case, they will do the confounded with the ABCD will do the confounding. They arrange all the alphabet here into the ABCD. Therefore, the ABCD will confounded with the block. So if the ABCD is confounded with the block, means that the information from the ABCD, you can test the information from here. Okay. So from here, we can calculate out the block effects, because you from the block 1 to the block 2. So we can know that from the block 1 to the block 2, the effect is negative 18.625. Okay. But if you want to calculate the sum or square for the block, we can use the sum from here. So the sum from here is a 405. The sum for the second block is 555. So therefore, we have a 406 square plus a 555 square divided by 8 of them. Why know that divided by 8? Because for each block consists of the 8 treatment combination. Okay, they have a 8 observation. Example is they run for the single replicate. So therefore, they only have a 8 observation here. Okay, so we divide 8 minus by the 961 square divided by 16. The 16 here is referred to the overall observation you run in this experiment. So from the 16 here, I know that we only run the 16 treatment combination, and then the n is equal to number of replicate is 1. Okay, they repeat only for 1 time. Therefore, this total is referred to the only for the single replicate. Okay, because the 1, A, B, all these things is referred to the total. Okay, but from here, from the formula here, we are notice that the n is equal to 1 in this example. Okay, so here I say that this really the effects of the block A plus the ABCD. Okay, means that the block here, the sum of square also the same thing. The sum of square is actually the sum of square of the block and the sum of square for ABCD are the same. So over here, I have two cases we can consider. Okay, because your n will be equal to 1. You are unable to calculate the sum of square will equal to 0. So if your n is equal to 1, we are unable to calculate the sum of square. Therefore, we have two options to consider how we're going to analyze our factors here. So one way is we can be assumed that all the 3-factor iteration are negligible. Okay, how about the 4-factor iteration? Because the 4-factor iteration, the ABCD already compounded with the block. So that one is already be block. So we can't find the SSABCD anymore. Okay, so therefore, if the first case is because of n is 1, we can be group all the sum of square 3-factor iteration together. Okay, where we think that the 3-factor iteration are not important, then we can be group them together to form your sum of square for error. Okay, so this one is the first choice you can consider. The second choice, if I do not know which factor are important or not important, then of course I will do the plotting of normal probability plot. But bear in mind that when you do the normal probability plot, you have a 2 power of 4. It's a 16. But you need to minus away the 1. You only can have a 15 factors together with all the iteration. But out of the 15 of them, you are confounded ABCD with the block. So you don't have the information for the ABCD. You need to exclude the ABCD. You only left is a 14 effects here. Okay, you only left is a 14 effects. Then you're plotting the normal probability plot also based on the 14 effects only. Okay, excluded the ABCD. Okay, then from the normal probability plot, then you can be checking out which are the important factors to be considered. Okay, those are the important factors to be considered. Then we will include it in the analysis of variance table. Okay, so you have two options. Either you choose the first one or you choose the second one. Okay, the first one is you automatically delete away those of them high order iteration. The second way is you just do the normal probability plot, checking which are the important one you remain in the model. Those are the important one you throw it to the error. Okay, so this is a ANOVA table. Okay, the analysis of variance table, where just now I have shown you how to calculate the sum of square for the block. So they put the bracket here ABCD to remind you that the block and the ABCD were together. So therefore, you only can calculate the sum of square for the block only. You are unable to calculate the sum of square for ABCD. Okay, so this one is for the sum of square for block. After that, they only list down those of the they're using the case number 2. Okay, they're using the case number 2 is those are the important factor. They will leave it in the model. Those of them not important one, we will put it. So the error here should be consist of the sum of square for error should be consist of the sum of square for the B plus a square for the here B is no more AB. Okay, plus the sum of square for the AB, AC, AD, BC, plus the sum of square for the BC, BD. Okay, plus the sum of square for the CD. These are the 2-factor iteration. Then of course you have all the 3-factor iteration. Okay. So how many of them? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13, and then you have one more is ABC, ABD, and then the BCD. Then you have a AB,
ACD.
ACD. Okay, thank you. ACD. Yeah. You have one more is a ACD. Okay. So the sum of square for the SSE here will be contained of all these sum of square. Okay. They inclusive the B as well. So means that by right we cannot say we excluded the B here because they're using the technique of the case number 2 here. They plot the Daniel one the Daniel plot, and then they excluded those of the not important factor. Therefore, those of the not important become your error. Then you only do the analysis of this part only. Okay, so you because this question they consist of the Nelson factors, so they excluded the sum of square for the block. Okay, so you have a sum of square block as an extra. Okay, then over here you totally can't see the ABCD because they were together. Okay, so this one is the idea of the doing the confounding. Okay, if you're willing to run less information, okay, you treatment combination under the certain block, then of course you will lose the information of the ABCD. Okay, so this one is the idea. How are we going to do for the confounding? So just now I have mentioned that confounding, you can confounding in terms of the 2 power of P blocks. So you can have a P is equal to 1. So you divide it into the 2 blocks. You also can divide it into the 4 blocks. You also can divide it into the 2 power of 3 is the 8 blocks and so on. Okay, it depends on how many Nelson factors, how many levels of the Nelson factor you have. Okay, if you only have a single Nelson factor, then you can apply these techniques. But even though you have a single Nelson factors, you also need to consider you have how many blocks you have. So if you have only 2 blocks, then it's possible you are using the confounding. If you have a 3 blocks, then you are able to do that. Okay. So the following one will be if we do the confounding in the 4 blocks. Okay, we do the confounding into the 4 blocks. So means that we can have 4 blocks of here. Okay, so how are we going to do the confounding of the 4 blocks? Okay, we do the confounding in the 4 blocks will be given as follows. The statistical analysis of this design is straightforward. Sum of square for all the effects are computed as no blocking and had occurred. Then the block sum of square is found by adding the sum of square for all the effect confounded with the block. Okay, so for the here, you want to calculate all the sum of square is as usual. Okay, so I repeat here, this statement actually is also applied for the above one. If you want to calculate the sum of square for all of them, you do the sum of square as usual. Use a contrast and then you square it out, divide the n times 2 power k. You will get all the sum of square. It's as usual. The only thing is you must bear in mind that you cannot calculate the sum of square for ABCD because you totally can't get it. Okay, and then yeah, this one is how do you calculate sum of square. Okay, so similar to the first statement of here, you calculate the sum of square for all the effects are computed as no blocking had it occurred. So then the block sum of square, if you want to calculate the block sum of square, is found by adding the sum of square for the effect confounded with the block. Okay, those are the effect confounded with the blocks one is you calculate the sum of square. Okay, so what is meaning of this thing? I will give you the example here. We have 5 factors here. We have a 2 power of 5 design. So they consist of the 5 factors. Each factor consists of the 2 levels. Okay, so we can be formed is a 2 power of where the p must be less than the k. Okay, because your k is equal to 5, so you can form the p is equal to 1. You can form the 2 blocks. You can form the p equal to 2 is a 4 blocks. So this is an example for the 4 blocks. So if you are looking for the 4 blocks, then of course if you refer back just now the example, if you want to do the confounding 2 blocks, you need 1 factor to be confounded. Another 2 blocks, you need another factor to be confounded. Okay. So here I will show you here If we do the confounding of the 4 blocks, we need the one factor to be confounded. And then another one also, you need to choose another factor to be confounded. So in this example, we don't choose, even though we have A, B, C, D, E. We have 5 factors. We don't choose the highest order iteration to be confounded. That is a reason one. Okay, for example, if you choose the first one is a B, E to be confounded, then you need to choose another one. So another one, I choose the second highest order. So the second higher order may be the second one, I will choose the A, B, C, D. Okay, so these two, I can do the confounding. So it's agree with just now I mentioned, we choose the highest order. But when you divide it into 4 blocks, you need to consider another of the confounding factors where is an iteration in between these two. Okay, the product of these two. So therefore, the product of these two, when the A times A, you do not have it anymore. So therefore, the one is a E to be confounded. C into the 4 blocks, you need the 2 factor to be confounded. This one is need 1 factor. This one is need another factor to be confounded. Where it show you here, this one is the first factor to be confounded. And then the iteration of these two, you have A, B, E, B, C, E. Okay, those of them is repeated. The E times E, you still have like the identity. So after that, you have only is E is missing. Then you have A, B, C, D. So this one is a 4 factor iteration is confounded. So all of them at the high level. If you choose the first factor is A, B, C, D, E, the second one is A, B, C, D, then when you confounded, the third one will be confounded, will be this one. So but the E will be important. Okay. So if you want to divide it into the 4 blocks, then you will lost 3 information. So if you choose in this the following combination, you will lose the information on E. So we are not doing this thing. Okay. So therefore, in this example, we will choose the first one is the ADE, BCE, and then finally we get the ABCD. So these 3 factors will be confounded together with the block. Means that these 3 factor information will be lost. Okay. Of course, this one is just the you can be choose the ABC, you can choose the other combination. Make sure that they don't touch on the main effect. The 3 factors here to be confounded one, make sure that they do, after they multiply of these two, do not consist of the main effect, the first thing. Normally, the 2 iteration also, you try to avoid it. Because 2 iteration effect, we still can be interpreted. Okay, then we still need to remain in our model. Okay. So this one is the idea. They do the confounding for the 4 blocks. So if they confounded in the 4 blocks, the treatment combination of course is minus minus will belong to the same block. The plus and minus, minus and plus, and then plus plus will be belong to the same blocks. So therefore you have a 4 blocks here. Okay. So later on I will show you the example here. Okay. So this one, the idea they can to the high order iteration. Okay. So for the following one is I give you in general. In general, we have a 2 power of k factorial design. We can divide it into the 2 power of p blocks. Not only the 2, you can be 4, can be 8, can be 16, and so on. Okay. So again, here I repeated just now the previous one. Your calculation of all the sum of square is as usual. Use a technique to calculate sum of square, but don't you are unable to calculate their sum of square. Okay. So this one is one of the tables to show it to you. Okay. If we have 3 factors here, okay, we have 3 factors. Then if you consider your treatment combination, you have a treatment combination is a 2 power of 3. You have 8 of them. Okay, 8 treatment be divided into the two blocks. Okay, you can divide it into two blocks. Each block contains of the 4 observations here. So you can be choose which one is to be confounded. So you can be choose the ABC to be confounded. Okay, you have a 3 factor. You have a 2 power 8 also. Instead of running for the 4 treatment in each block, you also can run in the 4 blocks. For each block, the size of the block is 2. So if you divide it into 4 blocks, then the size is 2. So what the effect you can be choose for the confounding should be the AB and the AC. Okay, you cannot choose the high order ABC. As I mentioned just now, if you choose the high order ABC, your remaining is another 2 factor iteration. Then when you do the consider the product, you will go you will end up with the mean effect. So that one is not the good choice. So therefore, the generate for the blocks will be use the AB and the AC. The product of these two, they get the BC. Okay, so let us go through the another one is 5 factors. Under the 5 factors, you can divide it blocks, 4 blocks, 8 blocks, and the 16 blocks, because the K must the P must be less than the K here. Okay, so if I only consist of the 2 blocks, of course I can choose the highest order iteration. Okay, as you can see, if you have 3 factors, I choose the highest order iteration. If for 4 factors, I choose the highest order iteration. If I just want to divide it into the 2 blocks. For the 5 factors, I divided in 2 blocks, I choose the highest order iteration. Then what is fine. For the 6 factors, I also choose the highest order iteration. But when we divide it into 4 blocks, 8 blocks, 16 blocks, and 32 blocks, then we need to choose it carefully. So we will see if you consider 5 factors, I want to divide it into the 4 blocks. Okay, then you need to choose the 3 factors here. Your product is end out is always the 3 factors. So they never touch on factors and the 2 iteration factors. Okay, this one is what we try to avoid. But sometimes, for example, in this one, the 4 factors with the 8 blocks, you still need to choose a 2 factor iteration. So you will lost all the information of the 2 factor iteration. AB, BC, CD, AC, BD, AD, you have lost this type of the information. Okay. So these are the iteration will be to be confounded. So this one you will lose the information, where the 2 factor iteration is also very important. Okay, so first thing we try to avoid it running in the higher block. If you have enough material to run your treatment combination, for the certain combination you have enough, we try to avoid it go to the higher block. Okay, so that one you will lose a lot of information. Okay. So this one is about this page. For your reference only. Okay, so I will stop until here for the here, because the following one is a partial confounding. This one I need to spend some time for discussing about this part. Okay, for the partial confounding. So this one is another section here. Okay, so I will continue this part in the next lecture, so that I will show you how to do that. Okay. This one is an idea of just a partial confounding.
Sorry, doctor.
Yeah.
Yeah, I want to ask. I don't understand why when we have more blocks, right, we have to confound with the the less more effects we have to choose to confound with.
Okay. Why? Let's say we give the example is 4 blocks here. Okay. We 4 blocks. Your question. Okay. You say we just we have 4 blocks. Why we have 3 confounded? Is it your question?
Yes.
Okay. So this one will related to the degree of freedom. If let's say you have 4 blocks, how many degree of freedom allocate for the 4 blocks? It's always a B minus 1. So you have 3 degree of freedom, correct? So you have 3 degree of freedom. Your degree of freedom is consists of the AB, AC. Therefore, you need to consider their iteration. So you all together you have a 3 factors to confounded, then it's equivalent to the 3 degree of freedom.
And for the effects, right, how do we choose again to generate the blocks?
For the effects, what effect is it? The effects, okay, the effects. So let's say you consider the ABC. You consider the factor is you have a A, B, C, D, E. You have 5 factors.
Yes.
You want to divide it into how many blocks? You want to have how many blocks? Let's say
4 blocks.
Okay, 4 blocks. So we can choose any combination. So normally we will go on to have a high order level. We choose the ABC, let's say. The first one ABC. I choose another one is can be CDE. CDE.
Yes.
Okay. So the iteration of these two, it should be the A, B, D, E. Okay. So you can be choose this one as your generate your blocks. You can choose this one as a consider as a factors where to be confounded. So this option will be fine because 3 factors will be missing. Then this one 4 iteration is fine. Okay, you can have another thing. If let's say I choose the ABC, I choose another one is a BCD. Okay, so if the iteration of these two, I will get the AD. Okay, product here. So I will lose the information on AD. So this one, I believe that the 2 iteration will be very important. So we do not choose this option.
Okay. So
okay. Of course, you have a many combination.
Yes.
Mm.
So there's no like a certain way for us to decide which one to choose unless we do like A, B, C, C, D, and then we see what is the interaction, is it?
Yes, yeah, you need to check it out because sometimes how the people will consider because they feel that the ABC is the important factor. If the ABC is they think that is the important factor, they don't want to confound it because the iteration also may be important. So therefore they don't choose. Sometimes it's based on their experience.
Oh, okay.
Yeah, we do not have a fixed way to, okay, which combination I need to choose. But as long as we don't want to touch on the 2-factor iteration, because this one is your one of the like the main factor and the 2 iteration will be quite important. The high order we can be give out the information.
So the goal is just to not to choose those lower order interaction as much as possible, is it?
Yeah, yeah. Okay. And then for your information, in this the blocking or the confounding technique, is it necessary or not necessary? Also depends on when you run your experiment. If let's say your experiment do not have a Nelson factor, so you no need to bother about this chapter about the blocking. Then if you have enough material to run your treatment combination, you also no need to bother about the confounding technique. Okay. So this chapter is just an optional. Similar to the previous, the chapter 3, I have mentioned to you, we study the factor, and then the chapter 4, we study the blocking, we study the Latin square. That one is just if you have a Nelson factor. If you do not have a Nelson factor, then it's fine. You can continue with just studying your own factors only. Okay.
Okay, thank you.
Yeah. Okay. So yeah. So this one I will stop until here. Next week I will continue with the the partial confounding. Before we start the tutorial question, okay, I think I let you know about this thing first. Okay, so about your test number 1, as you refer to the as you refer to the here the cost the cost information. Okay, the cost information. So we consist of the 2 tests, the test 1, the test 2, and the group assignment. So this group assignment I still not give you yet. Okay, so this one is I will ask you to refer to the get from the journals, the information you get from the journal one. This one is like the take home exercise. So this one I will give you later for the group assignment. For the test 1 and test 2, as I mentioned before, I in the week number 7. So therefore, this week is a week 5. Our test is will be scheduled on the week 7. Okay, before you have a break, semester break. So let us go through here. So this information actually I still hide from the student first. I still not updated the latest one yet. Okay, so tentatively I will plan to have here the test. We will start with the 10 minutes past 6 until the 10 minutes past 7. Okay, our test is just 1 hour, because you need to download the question and then upload back to the here. Okay, I will create the link, then let you to upload your question. Okay, I create the link here, then you can upload your question here. So because when you upload your question, you need to scan your solutions, all these things. So I will give the time 10 minutes for you to upload the solution. Therefore, our exam will be, you need to submit at 7:30. So for the here, for the test number 1, okay, I will let you to have a freedom. If you want to use the software to do the calculation, also can, but not all the question you can be calculate using the software. Okay, so you make sure that you know how to calculate. Same like the previous tutorial, I have shared with you the calculation of the get the sum of square for the first the 2-factor iteration, the 2 factors. Okay, or the the previous tutorial, suppose it's not the factorial yet, I give you the single factor analysis. Okay, so in the test number 1 here, I will cover just the tutorial 1 and the tutorial 2. Okay, so you have a question to answering the question, answer give the reason. You have a question to perform the calculation. Okay, so there are 2 questions where, of course, if question consists of the subsection. Okay, so you can refer to your materials during your answering the test 1. Okay, and then yeah, I try to put it as a 6:10 because sometimes some student will be late to join the class, and then I also want to make sure that it's before the 7:30. Therefore, I will put in this very odd time from the 6:10 to the 7:10. Okay. So this one, I will remind all the students again next week, because we have the test is on the week number 7. Week number 7 is the 1st of the December, Wednesday. Okay. This one is the first information I have. Okay. So the second thing is yeah. Okay. So for the week number 6, we will continue. Yeah. Later on, I will complete this part. Okay. So for the tutorial, for the tutorial 2, okay, for the tutorial 2, I believe that I have uploaded the question here. Okay, I need to let you know that for the question number here, okay. So in this tutorial, basically in the tutorial 2, I have a question is come from the factorial analysis, where you make sure that you're familiar with the factorial analysis. Because for your information, the test for this course will be very standard. What I mean the standard is means that the whatever you study is just you have a different type of the design only. Means that you have a factorial design, you have 2 power k factorial design, you have a blocking design, you have a completely randomized design, you have all this design. So if you fail it, I believe that this course will be quite similar, at least from today until from the first day of the lecture until today. Their calculation, the calculation wise, the formula wise, you can see that most of the time you will see the sum of square, the mean square, the error, the model, the residue. They are quite standard, at least until today. Okay, maybe that you have a slightly changes. Okay, but at least until today will be quite consistent. Okay, so in your question number here, the 5.6 here. Okay, this time I do not calculate only for you, but of course I can be show it to you also the solution, because I don't work it out the manual calculation. Okay, so in the question number 5.6 is studying for the two factor okay, where they study on the temperature and the pressure. Okay, so as usual, the question will be asked you is analyze the data. After you obtain the data, then of course you need to analyze your data. Okay, because we do not run the experiment by ourselves, so therefore we only get the data from the output. So this one is the year of chemical process they're going to study. Okay. Yeah, then there are 3 levels of the each factor are selected with 2 replicates is performed. So this is the result is given here. Okay, so this one is for each one you run for the 2 times. Okay, let me take out this thing. Okay, so in this case, okay. Okay, in this you have the temperature is the first one. They will refer to the pressure one. So the temperature consists of the A equal to 3 levels. If we're using our usual notation, it's a 3 levels. For the pressure, is we use a bit notation as a B. So the B is equal to the 3 levels. So therefore, there is a two observation here. So we use a notation, the N is equal to the 2. They repeat for 2 times. Okay, so if you want to analyze the data, of course, in this example, we will calculate the sum of square for the A. You need to calculate the sum of square for the B. You need to calculate the sum of square for the AB. Okay, then finally you can calculate the sum of square for the error. Okay, by finding the sum of square for the total first. Then you minus away the rest of the sum of square, you get the sum of square for error. Okay, so this question will be very standard, where they have a factor A, we have factor B, factor C, AB, and another one is a residue. Then of course you get the sum of square for total were given by here. Okay, the rest of them is not in your study for sum of square. Okay, so from all the sum of square here, you can be test whether which factor is considered as important. So I believe that you also need to familiar with the calculation of here. Okay, the formula you can refer to your notes, the lecture notes formula, or I believe that one student have shared you the books, so you can be read the books. You can know the formula, because during you do for the test 1 and the final test 2 and the final, sometimes the formula I will give you the raw data. Of course, I maybe give you just a 3 level and 2 levels. So I up to you. Want to use a software to do the analysis also can. The analysis, of course, you need to do some interpretation. Not only just use the routine calculation. So therefore, if the calculation, if you wish to use any software, up to you. You can be answer, then you submit to me. I'm fine for the test, okay, or for the final exam. But sometimes, as I mentioned, I will leave it as an empty. So I ask you to estimate this value first. So therefore, you need to know some skill to estimate it first. Then only you can be do the analysis. Okay, so the question sometimes will be direct. If give you the data will direct. If I say that this cell is a missing, so can you estimate this point first? Of course I will give you the constraint to I give you the condition to estimate it. Okay, you can do the analysis. Okay. So of course, yeah.
Excuse me. Yeah,
Anything?
if we don't use a computer, will we, and we just use our hand, will we be able to do it fast enough in the time given?
Can, because I never will ask you to calculate very huge data. It's 2 by 2. It's a 2 factors. I won't be asked you for the calculation of the 3 by 3 or this thing. Okay. So you use a software. Also, you need to familiar with the codes. If you never touch on the codes, you will face. Okay, so my I allocate the time is you use a manual. I will put the what consider all the students if they use a manual, because now I don't have the Minitab at with me, so that we can't analyze it. So I will set the exam question is according to, if you do it manually, you can be settle it. Okay.
Okay, thank you.
Yeah, yeah. Yeah. You sure can be settled one. Okay. Yeah. Okay.
I have a question. So since that you will ask the question that can be mentioned, so are you asking for drawing residual plot for any graph?
No. As I mentioned earlier in the previous few lecture class, I don't ask you to do any of the plot. Okay, if I want, I will give to you. For the tutorial, I pass it to you is because I need to let you know about the residue or this thing. Okay, I never ask you about the drawing the graph. Okay, then about this thing, about the 20 minutes here. Is it you are referring the 20 minutes here? Is it? Hello?
Yes.
Yeah, okay. Because your exam is this 1 hour. But after you complete the exam, you need the time to scan your solution. Then you submit it to me. So usually they will give you the 20 minutes to do the scanning, because sometimes your computer is net line is down. So therefore I give you 20 minutes to upload your solution. Okay, your exam is just 1 hour. But of course, even though I say it's 1 hour, I give you the flexibility is you can extend a bit. For me, it's fine. Okay, but you need to submit, no matter how, you need to submit your solution through the Spectrum, where I add on the one link, then you can submit your solution before 7:30. Okay.
Thank you, Doctor.
Yeah, okay. So in the usual one, if I given you, let's say, this type of the data, if you use the manually, because now we don't have the software with us, so therefore I believe that some of you, maybe you are using the manual calculation. So you use a manual calculation, of course you definitely can settle it, because the exam question I won't be set very long, so that everybody can settle it within the time, if you know you have a practice before. Okay, because we cannot calculate, because we also need to know how this one, the formula is come from. Okay, if you learn the statistic course, you need to know about all this background. You cannot just blindly just take out, then you continue to do it. Okay, so at least I have mentioned it to you how the sum of squares come from here. Okay. So for the first question, we'll be doing the analysis and then draw the conclusion. Okay. On the result here, based on the result here, we can be observed that the AB will be not important. The AD will be not important here. The AB, the iteration is not important here, where the factor A and factor B will be significant. Okay. So another thing is, if you do it manually, of course you cannot get your p-value. You cannot get your p-value. Okay. So you not necessarily also need to get your p-value. If you have a f-value from the table, the statistical table of the f-value, to find the critical value, then you can compare it. Okay, so the statistical table, I will attach it together. But of course, also you can do that. Okay. So the first question is just show you that the A and B are significant where the iteration is not, as you can see from here. Okay. Of course, we need to compare with a certain level is a 5%. So they are the p-value were greater than 5%. Therefore, the AB is not significant. Okay. So when we want to interpret about the factor A and factor B, we can be directly interpret it out. Okay. So if the A and B, they have a significant difference. So because this one is looking at the chemical process, so we want to have a higher or better. So among 150, 160, 170, which level are you consider? Then you need to perform the multiple compare the Tukey test, the LST test. Okay. So after that you analyze, you also want to confirm that whether your residual plot is reasonable or not for the model adequacy. Okay. So for this part, as I mentioned, don't ask you to do the plotting. The plotting is just for the exercise only. Okay. If you have a software, then you can do the exercise here. If you don't have, also doesn't matter here. Okay, just for showing you the results only. So as you observe it here, this plot is do not show very much that the residue versus predicted, they do not really have a very unusual pattern. Still can accept it. As I mentioned just now in the previous example, we do the transformation. If your plot is very obvious, then you may need the transformation. But you do the transformation, you will need to find the suitable transformation. Okay, the suitable function for the transformation. What I say suitable is you need to try. You need to try y square, the ln y, the exponential, or the y power of reciprocal, and so on. You need to try many times, then you only get the satisfied results. Okay. So this one is over here. Okay, and then a while here. About this thing, okay, under what condition you operate the process of here. Okay, so because the factor A and factor B is no iteration at all, so in that case we are looking at the which factor the pressure levels. Okay, we are looking at the highest means. Okay, and the temperature also we get the highest means, then we consider that is the factors you consider. Okay. And then over here, you can see that this one is the mean. This one is a mean for the pressure. This one is a mean for the pressure, the mean for the three pressure. So the highest one is a number 2. Okay, the number 2 here, for the pressure, number 2 is a 215. So therefore, you can see that you take the pressure is a 215. Use the Tukey mean to determine which level of the factor are significant different from the data in the problem here. Okay, in the same problem here. Okay, so we can use the Tukey test to do the comparison of the Tukey test. So of course, the Tukey test, you need to get the Q value from the software or you from the table. The table I have attached in the statistic. The table, if I'm not mistaken, I have put it here. Either I put it here, yeah, the tables I have put it here. Okay, I have put it here. So you can be use the Tukey tables. The tables of the Tukeys, it's not this one, it's a Q1. Yeah, here. Okay, you can be used different alpha level. This one 0.01, this one is a 0.05. Okay, so you can use this table. Okay, and then you get the critical value. Then you find out whether there are significant difference. Which one is have a significant difference? Which one is no significant difference? Okay, so if you check it out, 2 and 3 is great. So 2 and 3 there is a significant difference. 1 and 2 also significant difference, but the 1 and 3 were less than here. So means that in the result here, these two. Okay, so number 2 here is different from these two. So if you operate, your condition is you want to have a minimum value or the small value, so you can operate at the level 3. Level 3 is referred to the 3 here. The 3 here is referred to the, they put the 1, 2, 3 here. So you operate at the 230 or operate at the 200 will be get the same yield if you're looking for the minimum. If you want to have a maximum one, then your pressure must be 215 here is referred to number 2. Okay, the 215 is referred to number 2 here, also 19.8. Okay, so in this result here, it show you that you should, if you want to have a, should be choose the number 2. Number 2 is the pressure at the 215. Okay. Then in this example also we can be do it separately, because based on ANOVA analysis of variance table, we can see that the iteration is not significant. So you can be. So this one is your question number 5.6. Okay. So another thing is here, the conclusion is here, it shows you that 210 and here. So one actually, the 2 here is referred to 215. Okay. Then the 1 here is referred to the, there is a significant with the 215 and 230. So the 3 here is equal to 230 if I'm not wrong. Then 1 here is referred to the 200. Okay, the meaning of 1 and the 3 here, 1, 2, 3 here. Okay. So there is a significant, the difference in between the 200 and 230 is not significant. Okay, 200 and 230. Okay, 1 and 3 is no significant because it's a because of them is a less than, so it's not considered as a no significant difference. Okay. So I only can be explained to you here, but when you're working, I believe that I don't give you many questions. You better try to work it out yourself. Okay, calculation. Don't be panic during the exam time. You will be don't know which formula you should be used. Okay, so I believe that you don't want to try many questions, but at least you have tried one so that you're familiar with one of them. Okay. So for the first question is here. For the second question and third question, in fact, I don't ask you to derive it. In fact, I want to show it to you. This is an expectation. So for the test one, I won't be asked you to do some proving. I do not ask you to do any proving. So in the question of here, here 5.14 and the 1.17, in fact, I do not ask you to derive. I just want to show it to you, the expected value of the MSA, MSB, and the MSAB. Why I show you to you this thing is because when you have an expected value of the MSE is equal to sigma square. Okay, expected for the MSE is actually equal to sigma square. This one I think I have mentioned it to you. The expected for MSA, MSB, MSC, they always have a sigma square plus another component. If you're talking about a factor B, they have a beta B square. If you're talking about AB, you have a tau beta square. Okay, then after that, you can see that formula will consistently. If the A, you study a factor A, they will divide it by A minus 1. If they study a B, they will divide it by B minus 1. This one is because of their degree of freedom. And then you are looking for the AB, will divide it by A minus 1. Then the in front here, the coefficient, will be, actually, they have a standard formula. If you are studying the factor A, those of the levels is not involved one, you will write here. In this example, we only study the only one observation. So therefore, you only have an I is from 1 until the A level, the J 1, 2 until the B. Okay, you only study these two, but because you only have the single observation, So if you study the K is only, you also no need to put it here. You don't have the N observation here. You only have 1. So therefore, the K is equal to 1. So when you consider the MA, MSB, MSC, you can see the pattern. Just now I have explained this part to you. The front here will depends on what are the, if you study the factor A, then you write the B. If you study the B, you only write the A here. If you study the AB, you do not have, because the AB already here. So here you don't have anything. It's actually the 1. But if your replicate is N is more than 1, if you have an replicate less than 1, then here you have an NB. Here you have an NA. Here you have an N. Okay, the formula will be quite standard. They are consistently the same. Okay, and then under this expectation, we will also see that when you're testing the F test, MSA divided by MSE, you also can testing the factor B. You also can test the factor AB. Okay, so this one, when you're testing the factor A here, if the factor A is not significant, so in fact, the mean square A and the MSE will be approximately the same, is equal to 1 if they are not significant. Therefore, you can see here, if your tau is not significant, so the tau square also 0. So this part will be 0. You have a MSA is a sigma square. Your MSE also is a sigma square. Therefore, they will get approximately equal to 1. But if the tau I here, there is a significant difference, then you have an extra component for your MSA here. So therefore, you get this one will be larger value than here. Your value will be larger than 1. Okay, similarly for the MSB and the NSAB. So this one is why I give it to you, this formula here. Okay, and then if from the 2 factors, you go to the 3 factors. Okay, your 3 factors here, they do not have a complete set of here. So under these 3 factors here, the we have I is equal to here, J is here, K is here. So means that you also have a single replicate as well, because the as mentioned by here. Okay, so your model will be what? Your model consists of the main factor and the 2 factor iteration only. The remaining of the factor is not in the model. So how about the remaining one? They will group to the error here. So when you do the calculation of the sum of square, you only have A, B, C, AB, and AC. The remaining one will go to the error. Okay. So just now, if you see the expectation, if you are studying the factor A, you have a tau I square. Study a factor B, beta J square, gamma K. Then AB is a tau beta, beta gamma. Okay. And then the bottom here divided by their degree of freedom. And then if you put the BC here, if you study the B, you get the AC. If you study the C, you get the AB. If you study the AB, you left only C. All the expected mean square will be consistently the same formula. Okay, so this one is I just want to show it to you the expectation so that we related to this concept. Okay, if they are no different, the sigma square will equal to sigma square. The answer will be equal to 1. If they are back here, the answer will be more than 1. Okay, so the MSA will larger than the MSE. Okay, so for the 0.14 and 5.17, you no need to do anything. Okay, I just want to explain it to you about this here only. But in this example, in this tutorial, I only give you one question tutorial only. Okay, of course, you can be try another example is from your lecture notes, because the lecture notes, I give you the final answer. Okay, in the lecture note, I don't show you the step-by-step calculation. Then you can be practice from there. Okay, another one I show it to you is example 6.1, where you have here. This one is also the factorial design, but this one is a specific case, the special 2 power or 2 factorial design. If you want to perform it using the similar formula in the question number 5.6, also is possible. But if you want to use this one as a 2 power k, then you can use a simple formula by calculating their contrast. So for this case, you study for the 2 factors, and then for the 2 factors, you have a n is equal to 4. You repeat for 4 times, okay? And then the A is equal to 2, the B will equal to 2 as well. You study the 2 levels, and then you have four levels. The n equal to 4, they have repeated 4. Okay. So if this one is a notation of the treatment combination here. So if you want to list it down, the contrast, the one here should be the total of here. Okay. The one here is should be a total is a 64.4. Okay. So refer to the total. Okay, you can calculate out. Okay, what you need to know is a total. So once you get your total, you can form the plus minus table to find out the contrast. So from the contrast, you can calculate your, against this one is a factor A, B, AB. Okay, so maybe here I just show you there's a A. How we get it? This one will be the okay. So to get your A here, the A sum or square, the sum or square for the A will equal to the contrast square divided by n times 2 power k. Okay, so the contrast will depend on the sign here. So if you are looking at the A here, this one is a sign for the A. So you have minus 1 plus the here. So you have a minus 64.4 plus 96.1. This one, 2, 3. Similar to here. Okay, so how do you calculate? You can see from here how I do it. So therefore, if you're 2 by 2 matrix, 2 power k1, you can be used easily this thing. Okay, so this one is a get out the first one, the second one, the third one. Then after that, you have a residue. By calculating the total, you minus away, you get the residue. Okay, so this example 6.1 will be similar to the 5.6, where it's a factorial analysis. Okay. Huh? So this one is against the residual plots to check whether they fulfill the assumption or not. Okay, I believe that this textbook, the example, most of them is from the real example. It's not the artificial. Okay, so therefore they will give it to you the source of the data, where they come from. Okay. So whether this is a result, is the iteration is working or no, then we refer to the here. We refer to the result here. We also saw that these three factor A, B, and AB are significant. So when the iterations are significant, then when we interpret the A, we need to care about the B. Okay, because the AB in iteration is significant. So we need to take care about the these two. We cannot interpret it separately. We need to take care about the AB. Okay. So this one is where you need to draw the AB iteration plot. Okay. So the AD iteration plot, I think I have given it to you in your lecture notes. Okay, in your lecture notes for the factorial design. Not this one. Maybe it's not this example. Okay, you can recheck back what the example I mentioned about plot there. Okay, maybe it's the iteration plot will be here. Yeah, here. Okay, then you will know that under this level, what is the possible another combination will be possible to get the optimal solution. Okay. Any of you have question? Okay, I do not give you many of the tutorial question. Okay, so for the 2 power k, because 2 power k will be affected a lot, so therefore I will give you some more the 2 power k in the tutorial 3. Okay, so in the tutorial 3, I will give you the 2 power k and so on. But in this tutorial, I just give you the only one question from the factorial analysis. Because if I give you as a 3 factors, your calculation will be. Therefore, I don't want to give you the repeated work. Okay, but this one I never show it to you. You try to calculate yourself, see whether you are able to work out. Okay, it's work out the value is similar to here. Okay. Any more questions? So before you go for the test, we still meet next week. So next week I will remind you again what you need to take care about it. Then when you deal with the calculation here, make sure that you know how to do that. Okay. So if you do not have any question, that's all for today. I will upload the new tutorial maybe this Fridays or the Saturday. I will upload the question and the latest notes because I still the notes. Okay. So if you do not have any question, I think that's all. Okay.
Doctor.
Yeah.
I just want to check what's the scope for